Why do your cells rebel? Well, the biology of DNA, cancer, and the optimization trap involves unchecked growth. From DNA mutation to systemic malignancy, this is going to be a deep dive into the mechanisms of cancer, framing the disease not as just some random event, but as a systemic failure of biological regulation. So we'll explore the seed, which is the DNA, the soil, IGF-1, which we'll get into, and the trigger, oxidative stress. So what is the optimization trap exactly? Well, why superhuman AI and cancer share the same deadly code is probably a better question. So on the left here, you have the algorithm, artificial super intelligence, where you're probably familiar with AI, which is artificial intelligence. Then there's AGI, artificial general intelligence, and then there's artificial super intelligence, which is the granddaddy of them all. And then on the right here, you have the biology, cellular malignancy, aka cancer. So the concept is cancer is not a singular event. It's a systemic failure of regulation. The parallel is similar to artificial superintelligence, alignment theory, where cancer represents unchecked optimization. The glitch, kind of like the glitch in the Matrix, well, cells revert to a primitive program, maximizing resource consumption, sugar, other things that feeds cancer, and like processed sugar specifically, and replication at the expense of the host organism, aka us. And here it says down here, if anyone builds it, everyone dies. That's from Eliezer Yudkowsky. So he applied this to biological cellular replication without checks. So bottom line, if things go unchecked, they get out of control, whether it's artificial intelligence as it advances to artificial superintelligence or the biology of cancer cells. So let's define the enemy though. So we have a systemic alert or a system alert here. We have lymph nodes, your thymus, spleen, bone marrow, a lot of different organs here or systems. The definition is a condition where body cells duplicate uncontrollably, invade healthy tissues, and compromise the host, aka us. The target? Well, cancer directly compromises immune function and cellular health. The reality is that cancer is rarely a foreign invader. It is your own cells decoupling from the body's survival strategy. And I kind of think of cancer as almost like zombies. So zombies used to be healthy humans, and then they got, invaded or bit or whatever it was by a virus that transformed them. And we know that, some cancers are due to viruses. So this is very relevant. And so what used to be healthy now is a zombie and invading other healthy humans and causing havoc, really. So let's talk about the seed, DNA mutation. The 95% statistic is this. It is estimated that 95% of cancers result from damage to DNA during a lifetime. So this includes lifestyle, environmental factors, and not, I repeat, not pre-existing genetic conditions. The primary drivers, you're like, well, what are these caused by? Well, radiation is one. So this is what can cause further DNA mutations. Free radical damage, especially from fried foods and other things. It could be internal, sourced from food and things like that, or division errors. And so the implication is this. If 95% is acquired, that means, there's good news here, 95% is potentially preventable or manageable via the metabolic environment, meaning what we do. So this is very important. This is empowering. The biological checks and balances. The ideal scenario is the body detects DNA errors and repairs them or induces apoptosis, which is programmed cell death. The failure, which is here, this failed checkpoint, it says unchecked replication, is when mutation is severe. Cells bypass these checkpoints. So on the left, you have this functional P53, which is a fancy scientific term for tumor suppression gene, tongue-tied. And then, so the cells will say, hey, there's some DNA damage. I'm either going to repair, great, or I'm going to die. Okay, so problem solved. But when there's that failed checkpoint, that's when the result is here. the mutated DNA is copied to new cells, creating a lineage of unchecked growth, similar to that zombie analogy I was saying. On the left is the healthy human cells, on the right is the zombie cells that are, multiplying out of control in a way that doesn't benefit the host. And that's the main problem of all this. Healthy cells benefit the host or us, unhealthy cells do not. So the soil of malignancy. So here you kind of see a little sprout of genetic mutation. This is low IGF-1 or insulin-like growth factor 1. And then on the right here, you have high IGF-1 where it's growing out of control with this genetic mutation. So the hypothesis is this. Genetics are the seed. The metabolic environment is the soil. The trigger, even with genetic damage, the seed, aka genetics, often cannot grow without the right fuel. Okay, so what's fueling this genetic mutation? Well, insulin-like growth factor 1. All right, this is huge. And let's talk about what that is exactly, because you may be scratching your head and be like, what is he talking about? Well, the protein paradox is what this is all about. So there's an association between protein intake and cancer mortality or death between the ages of 50 and 60 with this study here. So the switch is that T. Colin Campbell's research identified animal protein as a primary driver of IGF-1. So what is animal protein? Any living being that had eyes or a mother. This includes any type of beef, chicken, pork, fish, seafood, anything like that. The data shows that high protein intake in a middle-aged 50 to 65-year-old is linked to a four-fold or 400% increase in cancer mortality. The mechanism is IGF-1 stimulates tumor proliferation and inhibits apoptosis or programmed cell death. This is huge. So on the left here, you have relative risk of cancer mortality. On the bottom, you have protein intake in groups. So if you have low, this is specifically animal protein, then your relative risk of cancer mortality is low. Low protein, low risk of cancer mortality or cancer death. Moderate protein increases that risk, but when you have high animal protein, 400% increase. And this is just simply on what you're eating. This isn't including any of the other factors that we mentioned with regards to like radiation or other things like smoking or even alcohol. This is just what you're eating. So obviously this can be amplified. The body's emergency brake. So we have this IGF-BP, IGF brake pedal where, you have a leaf here. What does that mean? But we have the accelerator, which is IGF-1. So think of IGF-1 as that animal protein consumption. And the IGF brake pedal is, well, let's talk about it. The brake is IGF binding protein, IGF-BP, neutralizes excess IGF-1, rendering it harmless. This is huge. The dietary impact is that plant-based proteins do not spike IGF-1 and simultaneously increase IGF-BP levels. What does that mean? It means it's a double benefit by consuming plant-based proteins instead of animal-based proteins. So the outcome is this creates a hostile environment for cancer seed, preventing germination. So if you want to minimize your risk, eat more plant-based proteins, ideally 100% as a part of your diet. I know that's challenging for many people because that's not the norm in the standard American diet, the SAD diet, but this is the scientific reality. Well, let's talk about the molecular trigger now, oxidative stress. So we talked about maybe what you're eating or doing or not eating or not doing, but let's talk about what's happening on a atomic level, an atom level. So you have a stable atom here. It looks very symmetrical and great. Then you have a free radical. All right. So the definition is an imbalance between free radicals, which are atoms with unpaired electrons, and the body's antioxidants. The sources are metabolism, pollution, radiation, smoke. So if you think about these things, these are contributing to free radical damage, which damage DNA. And remember, DNA damage is what can lead to either healthy cells repairing or apoptosis, or they're going to turn into these zombie cells and multiply out of control, which is cancer. The danger is that free radicals are unstable right here and desperate and are desperate to steal an electron to regain balance. So if free radicals cause DNA damage and they're desperate for that stable atom, or from an antioxidant ideally, the question is, are you getting enough antioxidants in your diet to help stabilize these on a atomic level? I mean, you have a cellular level, and then when you go down even further, you have DNA level, and then when you go down even further, you have atomic level. This is happening on a scale that's so small, but it's happening tons and tons and times over here. All right, so the domino effect of this damage. Let's talk about it. So step one, you have this free radical here, boom, and then you have a DNA strand, boom. So DNA is within your cells, your red blood cells, your things like that. So there's an electron jump from the DNA to this free radical. This radicalized and broken DNA occurs as a result, and then it creates this radicalized protein, which is not good. So you can see literally it unraveling, getting crazy. You've heard of, radical political activists. Well, this is a radical protein. So something separate but similar in the crazy. It's going crazy, right? So the chain reaction here is that unchecked free radicals steal electrons from healthy atoms, DNA, proteins, tissue. And the cascade effect is that this theft creates new free radicals. So it's not enough that one DNA is being affected. This is creating literally a domino effect and cascading into systemic cellular damage. This is an issue. This is a domino effect that's not good. The link is that this oxidative damage is a primary driver of the DNA mutations discussed earlier. Now, how do we restore the balance, right? Because you're like, oh my goodness, that was such a bad story. What's the solution? Well, you have this antioxidant here. There's a lot of antioxidant-rich plant foods. But what it does is it donates to a free radical, and it neutralizes the molecule. It stops that negative domino effect. So the hero is antioxidants. These are found in plants, essential oils, and vitamins. And ideally, these are whole food plant-based sourced, and ideally from a high quality brand I use as well, and then plant foods. So the mechanism here is antioxidants define biological altruism, or giving of goodwill here. They donate an electron to the free radical without, this is key, becoming unstable themselves. So imagine you have something of abundance, whether it be money or shoes or clothes, and you're able to give those to Goodwill or give those to somebody without affecting your ability to wear clothes or your ability to pay your own bills and things like that. That's amazing. That's what an antioxidant is. They're able to give without sacrificing their own ability to stay stable. And we all want to be stable, right? Ideally. So the result is the chain reaction is quenched. The DNA is protected. This is great news. And let's talk about the lipophilic advantage. So you have water-soluble supplements, and then you have essential oils, which I can actually go through here. So there's a little barrier. So cell membranes are fat barriers. You see here, that's what's going on here. Water and oil don't mix. You've probably heard that saying. The key is that essential oils are lipophilic, or fat-loving. All right? Who doesn't love some fat? Well, essential oils do, and are extremely low molecule weights. So they don't weigh much, and they're able to pass through and get to where they need to go to. This permeability, or ability to pass through directly into the cell membranes to address oxidative stress inside the cell, is where the DNA damage occurs, but also can be helped with these particular essential oils, which is great, right? We're going to help the DNA. We're going to help the inside of the cells, the nucleus, and other cell structures inside, not just on the outside. Very important. So let's deconstruct the system. Okay, this is a little summary. So we have the seed here. 95% of cancer is driven by acquired damage through basically diet and lifestyle choices, not fate or just your genetics. Some people may be like, well, that means 5% is. Well, if 95% of something is within your control, isn't that a good story? That's a good news, right? So how can we minimize it down to only 5%? And I've seen some other YouTube videos and other things, studies where it showed, anywhere from 1 to 10% is what they say cancer is, sourced genetically. So that means 1 to 10% of cancer is caused from your genetics, meaning, I have no control, right? This is kind of a middle ground based on this particular study it was pulled from, where 95%, or 5% could be, from your genetics. But the good news is there's the soil. Well, animal protein drives IGF-1 or insulin-like growth factor 1. It's what turns a baby calf into a full-grown cow. It tells cells to grow, which is great. However, it can turn, or tell benign non-cancerous cells to, grow. And then when they become out of control, that metastasizes and turns into tumors and they grow out of control, that zombie effect. So that is, though, this animal protein is the fuel that allows the mutated seed to grow unchecked. So everyone here who's like, I'm against seed oils, okay, that's fine, do that. There's a lot of oils that aren't good for you. And there's the people who are like, oh, I'm going to go carnivore diet. Well, do you want to increase or decrease your risk of cancer in the future is my question. But let's talk about the trigger, though, from that. Oxidative stress fractures DNA, so antioxidants act as the shield to prevent this damage. This is on an atomic level, very, very tiny, right? And so we have the defined mechanism here, all right? Now we must explore the solution. We know how it happens. We know how cancer happens. So many problems don't have a root cause defined. So many problems have a solution that doesn't address the root cause. We now know what that is here, and you can be empowered with that information. Now the challenge is executing, but hey, I'm here to help inform. Let's talk about my story. So my story, this picture is taken in 1990. We have my mom here on the left, myself about 4 years old, and then my father. So why do I bring this picture up, as well as the one with James Cancer Hospital and Solove Research Institute in Columbus, Ohio, present day? Well, I was born and raised in Columbus, Ohio, and my dad, when I was about 10 years old, he found something on his pillow. It was an infection. Come to find out, he had throat cancer. He was an alcoholic. He drank alcohol a lot of his life. I mean, there's unhealed trauma. There's a lot of probably root causes for that. But that is what definitely contributed to his throat cancer. He opted for the modern approach with chemotherapy specifically and radiation. And so that chemotherapy, though, is what he had an allergic reaction to. And he passed away early when I was 10 because of that. So he had, my mom and him had me when they were about 37, and he passed away when he was 47. And this picture on the right is where it happened. So this happened when I was 10 years old. Now this building has become a lot more fancy and bigger and better looking. These buildings don't get big for no reason. They get big because of all the treatments that don't address the root cause of what's going on with the cancer. They just mask symptoms and offer treatments that many chemotherapy doctors wouldn't even give their own family members. And I lost my dad at a very early age and had to grow up fast because I didn't have this information. And that's why I'm so passionate about this information today, and why I'm doing this video and many others in the future here. It's because I would love to have my dad back, and I don't have the opportunity. But I have the opportunity to help myself minimize risk and help others who are open-minded. So what's coming next? Well, we have the standard of care versus metabolic therapies to talk about in the next video, which includes the efficacy or effectiveness and toxicity of chemotherapy and radiation, aka the scorched earth method, and then targeted support versus systemic destruction, on top of specific essential oil protocols, including frankincense and sandalwood, and their research-backed mechanisms. And so in part 2, make sure to watch the standard versus metabolic care. And finally, critical context and a medical disclaimer. So the information presented in this series is for educational purposes only. It's not intended to diagnose, treat, cure, or prevent any disease. And essential oils and metabolic therapies discussed herein are not FDA-approved cancer treatments. The protocols described are based on historical usage and specific peer-reviewed studies, but individual results may vary, obviously because of diet and lifestyle things. And always consult with a qualified healthcare professional. That includes oncologists, integrative specialists, as well as naturopath or homeopathic doctors before altering your standard of care or incorporating new supplements. And with that said, make sure to check out the next video in the description area below, the pinned comment for natural solutions for your health. Appreciate you watching, and we'll see you in the next video.